In 5.6a, you are going to have to create some things. You are going to have to create some parallelograms on a coordinate plane, which means that there's going to be graph paper. They're going to give you 3 points, and you're expected to figure out where the 4th point is supposed to go. But the first thing they do is they're going to say in quadrant 2, or in quadrant 1, or in quadrant 4. So you have to know your quadrants. If you do not know your quadrants, you can't answer the question correctly. So if you don't know your quadrants, quadrant 1 is it where it's positive, positive. This is quadrant 1. Anything over here is in quadrant 2. Actually, let me see if I can draw an XY axis here. Let's see if I can do that and move that right there. That looks a lot better. There we go. 1, 2, 3, 4 are your quadrants. You need to know that to be able to answer the question. The other things that you're going to need. Parallelograms have opposite sides that are parallel. I'm going to put and congruent. They are parallel and congruent. So what that means to you is if you are trying to find something that is a parallelogram, your slopes should be the same. Your distances should be the same. So I will show you what that means or what that looks like here in just a second, because I have 2 examples I have picked out for you. Number 1 will go by pretty quick. Number 4 will take us some time. Number 1, here we go. This is the first one on your worksheet. And it says, these points are plotted below. Plot a 4th point in quadrant 4 that will make a parallelogram. So I have to know which one is quadrant 4. 1, 2, 3, 4. This is quadrant 4. I got to have another point here that will make it a parallelogram. And so what you need to do, or you need to remember, is parallelograms have opposite sides that are parallel and congruent. If this is a distance of 1, 2, 3 units, then its opposite side should be 1, 2, 3 units away. What I can do is I can go, okay, from here, and I have to be in quadrant 4, 1, 2, 3 units away. I know where this point has to be. It has to be there. If I do this, 1, 2, 3, 1, 2, 3, that side is the same as that. The slope is the same. 1, 2, 1, 2. Then these 2 sides are the same. Their slopes are the same. This point is the point that would make a parallelogram that has to be that point in quadrant 4. What is the coordinate of that point? Count. 1, 2, 3, 4, 5. And down 1 is 5, comma, negative 1. Your answer for 1A should be 5, negative 1 for part A. And you should complete the sketch, which is what I did right there, to make a parallelogram. This one's a rectangle this time. You're going to get a chance to do that for number 2 and number 3. When you get to number 4, this is where the work becomes a lot more. So I am going to show you in detail how to do number 4. Number 4, there is quite a bit of work. So let's go ahead and start it. And I would recommend that as I do this problem, I would really, truly recommend that you write down pretty much everything that I write down as we do it. Let me shrink this down just a little bit. These points are plotted. Plot a 4th point in the indicated quadrant, then complete the sketch of the parallelogram. So I'm just going to focus in on this one. Plot a point in quadrant 2. Quadrant 1, quadrant 2. Verify the quadrant is a parallelogram by using the slope formula. So here's the deal. Here's quadrant 2. Let me write 2 right here. and I have to make a parallelogram that's somewhere over here, here's what I do. Well, there's this side. There's this side. How could I make a parallelogram with another point in quadrant 2? I need something that's going to be the same. It's going to be 1, 2, 1, 2 away. Let's see if this point works right there. If I do 1, 2, 1, 2, then these sides will be the same. If I go up 1, 2, over 2, up 1, oh, I'm sorry, up 2, over 2. That would work. Does that make a parallelogram? Are these sides parallel to each other? Yes, they look that way. That's what a lot of people would say. But what you're going to have to do is you're going to actually have to verify the quadrilateral is a parallelogram by using the slope formula. What does that mean? That means that you're going to have to figure out what this point is. It's negative 3, 3. You're going to have to figure out the other 3 points. This is 1, 3. This is negative 1, 3. Let me erase that real quick and change it. Negative 1, 3. This is negative 1, 1, and this is 1, 1. Now I have my 4 points. When you get your 4 points, you're going to have to use the slope formula to figure out, are the slopes the same? If you do not know where your formulas are, they are in your 4.1a notes. Slope, distance, and midpoint formulas are here. 4.1a notes. I will write them down again if you need them, but that's where you could find them. If I want to use the slope, then what I have to do is I have to do the y2 minus y1 over x2 minus x1. So I'm going to find the slope of the top piece and then find the slope of the bottom piece. I'm going to do the y2 minus the other y over the x minus a negative 1. Now, a lot of people forget when you subtract a negative to put 2 negatives there because it does make a difference. This is the slope of the top piece, which simplifies to 0 divided by negative 2, which is just 0. That makes sense. This has a slope of 0 because it's just horizontal. Let me check the bottom one. The slope of the bottom would be y2 minus y1 over x2 minus x1. I get 0 over negative 2, which is still 0. And what do we know about these two things? These two slopes are the same. It means that these two slopes are parallel. Well, we checked these two sides being parallel. Guess what? We still have to check these sides to make sure they're parallel. So I'm going to check these 2 points next. y2 minus y1 over x2 minus x1. I get 2 over negative 2. So this slope is equal to negative 1. And I have one more slope to check. This slope. Take my y2, subtract y1, take my x2, subtract my x1. 3 minus 2 is 2, negative 2. And what I notice is that the slopes are the same. When the slopes are the same, they are parallel. This is parallel to this. That is parallel to that. I now have that the opposite sides are parallel, and the slopes prove that it's a parallelogram. The next one that we're going to have to do is we're going to have to plot a point in quadrant 4 and use the distance formula to prove that it's a parallelogram. So I go to quadrant 4. 1, 2, 3, 4. 4 is down here. And I have this one and I have this one. So if I needed to be in quadrant 4 down here and I go down 2 units, I want to go down 2 units here, I'm pretty sure that that would make a parallelogram with the 4th point in quadrant 4. I'm going to write down these coordinates. This is 1, 1. This is negative 1, 1. And this is negative 1, 3. And this is 1, negative 1 there. The distance formula is this. The square root of x2 minus x1 squared plus y2 minus y1 squared. They use this a lot. It doesn't go away. They're going to use it in this unit, this chapter, and they're going to use it in next chapter as well, just so you know. So if I wanted to find this distance, I should say this, something about this real quick. Let me just say this. If it's on a line, if it is vertical and on something that is straight, when I say straight, I mean it's either on this x-axis or y-axis, or it goes straight vertically up and down or horizontally, I can just count. 1, 2 units. 1, 2 units. It's the diagonals that this is for. This is for the diagonals, really it is. Because we don't know how long that is. It's longer than this 2. So I can tell you that this distance on the left side, I'm going to put left side, is equal to 2 units. And the right side is equal to 2 units. I know that. I can just count it. I don't need the distance formula for something you can count. That doesn't make sense. But for diagonals, for distances that are longer because it's a hypotenuse, we need this distance formula to know how long this is. So here's what I'm going to do. I'm going to do this. I'm going to do the top is the square root of x. What? X2 minus x1. I'm going to take this x and subtract that x. Negative 1 minus 1 squared plus, awesome, 3 minus 1. And then I'm going to simplify that. Keep in mind, parentheses make a difference, especially on calculators. I have to tell you that to you because the number one mistake I see all the time is that negative 1 minus 1, parentheses squared. Some people don't punch it in with parentheses, and their calculator will show them a different answer. This is negative 2 times negative 2. Negative 2 times negative 2 is a positive 4. 3 minus 1 is 2. 2 squared is 4. I am going to recommend that if you do not know how to do this, use one of those Casio calculators that can actually reduce the square roots for you. Square root of 8 can be written as 2 root 2. If you remember, you can break this down into 2 times 4, 2 times 2, and pull out that 2. It's 2 root 2. That's that distance. It's longer than 2. It's 2 root 2. The bottom, on the other hand, I got to use the other coordinates to figure out what it is. I'm going to use the bottom coordinates. I'm going to do x1 minus x2 plus y1 minus y2 minus a negative. I want to see what that is. That's negative 2 squared, which is 4. 1 minus 1 is 2. 2 squared is 4. And guess what I get? I get the same distance using the distance formula. This is using that property that says when the opposite sides are congruent, then it must be a parallelogram. Does anybody still need it? Now I'm going to go to the last one. This is our last example, and then we'll be done with our notes. For 4, it says plot a point in quadrant 1. That makes it a parallelogram. So if I'm going to use quadrant 1's over here. I think up to, I think that would work, which would make a nice little square. And I'm going to plot these points. This is negative 1, 1, negative 1, 3, 1, 3, and 1, 1. This one asks you to prove it's a parallelogram by using the midpoint formula. Now, I didn't ever do this before this year. This is my first year doing this. If I know that the midpoint for this diagonal is in the same place as the midpoint of this diagonal, if those two midpoints are the same, then that means the diagonals bisect each other. And if the diagonals bisect each other, then it must be a parallelogram. So what we need to do is we need to check, is this diagonal, does its midpoint, does it the same as the other midpoint? Here's how you find out. We use the midpoint formula. The midpoint formula is the average of your x's and the average of your y's. All you have to do if you're finding that first midpoint, diagonal 1, is you add up your x's, negative 1 plus 1 over 2, and you add up your y's, 3 plus 1 over 2. Let's simplify that. That's 0 over 2, which is 0. And 4 over 2, which is 2. I know my first diagonal's midpoint is at 0, 2. And then if I want to find the diagonal of the second, the midpoint of the second diagonal, number 2, what I do is I take the x's, I add them together, negative 1 plus 1, 1 plus 3. Simplify, you get 0 divided by 2, which is 0, and 4 divided by 2, which is 2. These midpoints are the same. Because those midpoints are the same, they must mean that the diagonals bisect each other. Because the diagonals bisect each other, then it must be a parallelogram. That's the deal. This is the longest one that you had to do. I did it with you. Everything else, I think you should be able to do on your own. There's only one other thing that I need to mention, and we'll do more notes on it in 5.6, but slopes that are perpendicular. Slopes that are 90 degrees are opposite signs and reciprocals. So what that means is when you get to number 5 and you know one slope is negative 3 over 2 and the other slope is 2 over 3. If they are opposite signs and reciprocals, meaning flipped over, then those two lines are perpendicular. They have a right angle between them. That's how you're going to tell if it's a square or if it's not a square. I'm going to stop your notes right there.